final segment of the weather theory here for the junior ground school. We're going to pick this up on fronts where we talked about there before. Before we do, let's take a peek at this great land of ours and the weather that is happening to it. I'm going to hit the loop here, and you can see kind of what's going on here just a little bit here with some of this weather. You can see that here kind of in the central part of the U.S., central and south central part here of the U.S., we've got some thunderstorm activity that's kind of moving slowly west to east. You can see here in kind of the central part, kind of the northern central part, you can see some clouds, some snow actually kind of moving in here as well. You can see some weather moving in here from the Pacific Northwest. And this is coming in here, which will segue nicely into what we're about to talk about here. And we see some other weather up here in the northeast part of the country. We're going to be getting, and I think that you're going to start to see somewhere down here, down in the south, that blue dot right there, that's where I am right now. You can see that this weather is kind of getting pushed in here from weather coming in here from the southwest. So we've got some weather moving in here into our neck of the woods coming up here later on this afternoon and tonight. And we expect to kind of see this moving. This is sort of where we have this portion of this cold front sort of moving down here and going to be coming in here, creating some of the thunderstorm activity later on this afternoon and for most of the day tomorrow. So just giving you that little heads up. We'll take a look here at some of the latest surface analysis that we have. You can see here this cold front that we were talking about here before. This is that part that's kind of creating that weather there. This is that dry line. This is the type of thing that we start to see this time of year that's going to be generating a lot of the early to late afternoon into the evening thunderstorms that'll kind of sweep through the central portion of the United States. Cold fronts, we have a couple of different ones moving in here, one kind of from the north, we have another one that's a little bit further south. This warm front moving in here, it's this area here between this cold and this warm front that's creating the weather that we see here on the map. And so that's where this weather that we're looking at there right now, this is that portion of the cold front meeting that warm moist air right here. And this is why these storms are gathered up here just kind of east-northeast of Dallas and moving easterly here at not a too great a pace. Back to the latest surface analysis here. You can see the isobars. We see a little bit of lower pressure here, not hugely low, but you can tell that it's certainly a little lower than 1013.2. So that does put it a bit on the low side. Remember how that spins. It spins counterclockwise here. So that's kind of what's pulling this air in here into New Orleans, coming up from this direction, in addition to this low pressure system here, pulling the air up in kind of this anticyclonic rotation here, or counterclockwise or anti-clockwise, cyclonic circulation here. Then up here, so we have the cold front here with the blue, the warm fronts here with the red. We have a little bit of a stationary front right here, which kind of combines the red and the blue here also. And then we can see this part, and we're going to come back to this here in just a minute, where we see kind of this low pressure system here, which is a little bit lower and creating a bit of an occluded front. So we'll talk about those here momentarily. So with that, I am going to attempt to pull this out of the way there. Can I do that? I think I can. Hopefully I can. Oh, this thing, you know, I thought I had this set where I could do what I wanted to do here. I think maybe this is kind of the way I have to do it. There we go. Sorry about this, guys. I just needed to get over here where I could draw on some stuff when I need to. So I'm going to slide this out of the way here and pull that up as I need it. Now, back to the action. This is where we left off yesterday. So what I want to do is I want to show you, first of all, the fronts. What do we mean by a front? A front is going to be an area where we have a separation of temperature and wind direction. So we have a couple of different types of fronts that we'll talk about, but basically what they are, they're air masses that are moving in certain directions, and they're moving in certain directions because of the things that we talked about before, which is the uneven heating of the Earth's surface, creating convection here, a void there, stuff moves in to take its place. It's kind of the Archimedes principle. So, you know, for those of you that want to look that up, there you go. And so that's kind of what happens here, is that stuff moves around. We have predictable airflows that we have. We looked at those in the imagery here before, and we're going to look at those again here, this time a little bit more kind of a tighter look at things. So if we look here at the lower 48, we can see that we have blue arrows here and we have red arrows here. The blue arrows are going to be primarily cooler air. The red arrows are going to be primarily warmer air. If you look, this area is the arrows coming in from the north are going to be Arctic air. Then you have the maritime polar air, you have the continental polar air, and then you have more of the maritime air. Now, what does that mean? The maritime air spends most of its time with that air mass over water. So do you think it picks up a little moisture over the water? Yep. So that air typically tends to be a higher water content than it does if the air spends most of its time over land. So when we see a big cold front coming in from central Canada, let's say, and some people think that that stands for Canadian polar, but it's not, it's continental polar, is that air is going to be drier. So when we see a cold front pushing in from the north straight to the south, or even off this way just a little bit, the chances are that air is going to be very cold and dry. Now, when we look at the air coming in from the Pacific Northwest, the northern Pacific Ocean, or we see it coming in from the northern Atlantic Ocean being pulled in here, that air is going to be relatively moist because it's spent a lot of time over the water. So that's the big thing to kind of remember, is that in the wintertime, the big things that normally make our snows here in the central Rockies is this flow coming in here from the Pacific Northwest, or this maritime polar air moving through and coming over the land and creating the snows here. Now then, we are in a transition time frame here, and what I mean by that is that we're moving from winter into summer. So the two things that separate winter from summer is going to be spring and fall. So in the springtime, we start to see the air mass becoming a bit more unstable as temperatures really begin to change. As those temperatures change, we start seeing more and more air moving in from the south. So in this case, they're moving in here from more of a tropical type of an environment, indicated by the big T right there. Remember that the maritime means that is air that's moving in over land here that has spent a great deal of time over water. And then we also have another continental tropical that comes in here from South America, not necessarily South America, but at least Mexico, coming in where this air can be a bit more dry. So when we see these warm fronts moving in, if we see a warm front that has spent most of its time over Mexico, let's say, we know that air could be a bit more dry. And when we do that, the thing that I wanted to show you is that thing that we looked at earlier, which is that dry line. So remember, that's what this is right here, is a dry line. That means it is warm air, but it may not have the moisture to it that some of the other air might have. But what it does have is that it does have some instability potential in there as well, and a higher static type of a mass to it that can have more static electricity and create lightning with that, which can be a little bit different than just a traditional thunderstorm. Some of the weather that happens here in the south and kind of the desert south here through New Mexico, Arizona, and into western Texas, this is where we start to see some of these dry lines. It's not unusual to see that dry line moving up here into eastern Colorado as well, or in the panhandle of Texas and Oklahoma. So keep that in mind. So here, this is where we start having these battles. And it's when this warm, moist air meets this cold air right here, that is the kind of thing that creates this, where is it? Where's my map? Maps, there we go. That creates this, which again, cold front, warm front, thunderstorms. So that's the end result there when these things begin to happen. So remember this. We have 4 different types of fronts that we're going to be talking about. We have a warm front, cold front, stationary, and occluded. And you guys know by now that anytime that you see anything with red lettering, you know that those are going to be important categories. And anything that you see with bullet points underneath it, you're going to have to know what those are. Okay? So we look here, warm front, cold front, stationary, and occluded. A warm front, normally as it moves, it tends to move, compared to a cold front, it moves somewhat slowly. And so normally you'll see that air mass move around somewhere between 10 and 25 miles an hour. It's a bit more gentle, more so than the cold fronts. And then we also have a little bit of a difference in the way that a warm front moves and overtakes cold air. When that happens, you have the cold air here, here's the warm air here, and normally what happens is that as that warm air moves through, it kind of comes through and it sort of, I don't want to say like a steamroller because it's not quite that severe, but it kind of comes through like that and sort of squishes the cold air out of the way. Is sort of the way that happens, because it kind of comes through and sort of does that. It's a little bit different, but that's kind of a way to think about it anyway. So when we look at the movement of warm fronts here, here, I will talk about the warm fronts in just a second. But this shows you what we have talked about before. So when you see a warm front, you'll see it here with the red, and you have these little kind of these half circles on this thing. You think about warm front, think about sweat beads, okay? So little beads of sweat on that line, warm front right there. The blue lines here with these sharp points are cold front. So think about a cold front as kind of biting, you know, that biting front, you know, with fangs. Okay, so that's what you do when you think about a cold front. A stationary front is that front there where a cold and a warm front are kind of commingling, but there's not a lot of generalized movement going on. Air's just kind of sitting there. So when you see that, you're going to see the warm front stuff on one side and the cold front stuff on the other side of the line. Then you have what we call an occluded front. An occluded front, this is where now you've got a little bad juju. This is outside of thunderstorms, an area where we as pilots of small aircraft want to try to avoid these occluded areas when we can, because those occluded areas, that's where you have weather in a blender. Okay, so those are things that are very unpredictable, especially in light aircraft. So just remember those. You're going to be responsible for knowing what those are. To be able to identify them not just by color, but also by shape. Because sometimes these lines don't have colors with them, they just have the shapes. So you're going to have to be able to identify those by shape and or color. When we look at a warm front overtaking a cold front, let me move this out of the way here slightly. You can see what's happening here. So in the diagram or the image above, you can see a warm front moving from west to east and kind of moving toward Pittsburgh. And those of you that are geographically impaired, you'll kind of note that this air is kind of moving roughly east-northeast. As it's moving through. So again, what's happening is that you have this warm front overtaking a cold front, and it's kind of squishing that air out ahead of it. Nothing real violent. And when we look at this, we can see that what precedes this at this angle is we can see these high cirrus clouds going to precede this warm front moving through. So when we see those high cirrus clouds, these big wispy kind of horsetail looking crystals of ice, that is sort of a harbinger of a warm front moving into the area. Those are going to be replaced by some of the cirrostratus clouds. You can go back and look at the nomenclature on how clouds are done with the higher clouds here. Then you have the altostratus clouds, which are going to be these middle layer clouds, that are going to be, somewhere in that 6,500 feet to 20,000 foot range. And those are going to be more the layered clouds, more horizontal components to it. And then as we get closer here to the ground, and here with this leading edge of this front here, then you can see that you have rain, but it's mostly in the form of like a continuous rain. But it's not necessarily thunderstorms in nature. So keep this in mind, that this is sort of how a warm front overtakes a cold front. Keep in mind that as it kind of moves like this, and you have that boundary that precedes, that's at a higher altitude, that precedes the actual warm front moving through on the ground, that goes way out ahead of it. Like you can see this, the difference between St. Louis and Pittsburgh. So it's a pretty large geographic area there, which is about 600 miles away. So that's kind of how that looks. Now, when you look below that picture, you can also see what this looks like on the weather maps. So you can see that there's an area here of lower pressure here, and you have an area here where here at 1014, it's about normal, even a little higher pressure here. The one thing you can see is that you can start to see the difference here in what happens with these pressure, these isobars here as the front passes. And the two things that are always going to happen, the two things that will always happen during a frontal passage that separates the boundaries of fronts are going to be a change of temperature and a change of wind direction. Change of temperature, change of wind direction. Got it? So that is what you're seeing here as this front begins to move through. These METARs here, we've introduced those, but we don't talk about that until the next chapter. Okay, now then we talk about a cold front. A cold front moves quite a bit different than a warm front. Remember I told you that a warm front kind of moves through here, kind of like that, kind of gentle, somewhere in that 10 to 25 mile an hour movement range through this. A cold front is like a freight train. How many of you have seen these trains, kind of the old-fashioned trains that at the very front of the train on the locomotive part of it, down at the very bottom just above the tracks, you'll see this triangular shaped thing right there we used to call a cow catcher. So in other words, what would happen is that it would cut underneath anything on the tracks and kind of push it out of the way to make sure that the train doesn't derail by something standing on the tracks. Okay, it sounds a little barbaric, but that's kind of what it was. So you'd have that cow catcher to just kind of move stuff. Or you've seen some of the snow plows that kind of dig in like that and throw the snow out that way. That's what this is. These cold fronts move in like a freight train. These things are going to move anywhere from 25 to 30 miles an hour. It is not uncommon, however, to have these things move through at 60 miles an hour. And they dig in and they dive right underneath the warm fronts. And so what happens is that like with the warm front, you kind of start to see it kind of squish the cold air out of the way. A cold front comes in here, and that leading edge of the cold front is what drives all of that warm air straight up. And so everything behind that cold front is behind the ground edge because that air is so much more dense and cold that it'll stick to the ground. And that's why it comes in like this as opposed to a warm front like this. So when you're looking at that, these cold fronts, we're going to look at a picture of it here. I want to make sure that I'm not missing anything here. Yes. So here's a picture of what it looks like with a cold front overtaking warm air. You can see that leading edge of that cold air just digs down. All of the cold air is behind it, as opposed to the warm air, that warm air is preceding the actual ground portion of the warm front, and it can precede that by more than 600 miles. This, the leading edge of it, is on the ground, and it digs underneath that warm air, and it shoves that warm air straight up. And when that warm air is forced upward, that warm air cools. The warm, moist air cools because of the cold air with the cold front, and that's what creates these big cumulonimbus clouds. And those are going to be the clouds that can become thunderstorms. So the thing that we see here in the illustration prior to this is that, again, moving kind of east-northeast from St. Louis to Pittsburgh. At Pittsburgh, 600 miles away, you start to see some of these white fluffies. In Columbus and eastern part of Indianapolis, we start to see more of that vertical development preceding the actual cold front. But right there, where that leading edge of that cold air is hitting Indianapolis, they're putting storm clouds, the big cumulonimbus storm clouds, right over Indianapolis. So when we look down below at what that looks like, again, the blue teeth right here, that's going to be coming in. You'll notice here changes of temperatures, changes of wind direction as it's moving, the changes here in the isobar lines as that cold front moves through. Depending upon how quickly it's moving and how dense that air is will affect not just the temperature but also the velocity of this cold front as it's moving through. The METAR stuff, again, don't worry about that. We're going to talk about that here in a minute, but this is all code for what's happening at these airports as this cold front moves through. So cold fronts, as they move through underneath a warm front, those are the things that are normally the big weather producers, especially this time of year. Stationary front, that's going to be a front that just kind of separates a warm and a cold front. Those things could sit there for days, and they could just not move around very much. Occluded front. This is going to be something that accompanies a super low pressure system. This shows you here a picture of like an occluded front with sort of what happens right there. And again, it's weather in a blender. Normally, an occluded front will occur sort of in the eastern quadrant of a real tight low pressure system and can rotate around to the north of that pressure system depending upon how tight that low is. So for instance, when we look at this over the Great Lakes, we can see right now in that purple, or the little sweat bead and the little bitey triangle thing right there, just on that east side of that low pressure with that air getting sucked into that low, and that is creating bad juju. That is going to be very unstable air that we normally don't want to tangle with in light airplanes, because that can be kind of a big deal. So, excuse me, pardon me. So again, this shows you kind of what that's going to look like here with this occluded front. You'll notice here on this imagery, it's not purple. It just has the shapes. So you have the sweat beads and the pointy thingies over here on the same side that indicates an occluded front. And you can see the low pressure here as these isobars get tighter and tighter together to create, in this case, something of a closed low pressure system where all of that stuff gets sucked in here together, and it can create all kinds of chaos. So just understand that. The three stages of a thunderstorm. Remember, thunderstorms primarily are created when a cold front sweeps in underneath a warm front, shoving the warm, moist air straight up, creating these big cumulonimbus clouds, and these are the big weather producers that we can see for instance, like what we looked at here just a little while ago on this, because that's where this weather right now is coming from. It's coming from a cold front that is digging in underneath warm front, and shoving that warm, moist air straight up. Cools the air. There's the clouds because of it reaching the dew point, and you have tremendous vertical development of these clouds. And when I say that, you can see here right now that the tops of some of the clouds, and I'm going to stop this here so that we can see what some of the cloud tops are. Some of the cloud tops here, we have 21,800 feet here, 25,000 feet here. We have down here, we've got 35,000 feet are the tops of these clouds. Trying to see what it shows here on these. I'm not seeing a number. 30,000 there. What about these back here on the trailing side of that? 33,000 feet, the tops of these clouds here. Now, by the way, 35,000 feet tops of these thunderstorms right now, that ain't nothing. Because as I said before, some of these tops on some of these big storms and some of these big squall lines that can form, you're going to have tops that may exceed 60,000 feet. Some of these things are monsters. The energy that is in these storms is ridiculous. You don't want to tangle with them. Again, 20 nautical miles away from the footprint of these storms, minimum. And in some cases, you want to be further away than that. So keep that in mind. There's 3 stages to a thunderstorm. And by the way, these are going to be things that you're going to want to record. So you may need to come back to this video and watch this again. 1, 2, 3. The first stage is the cumulus stage. The cumulus stage is that part where now you have some kind of lifting action in an unstable, moist environment where the air is being forced up or drawn up. And what happens is that as that air rises, reaches the dew point, the cloud base begins to form, and all of this is associated with what we call updrafts. All of the air is being pulled in underneath this cloud with everything here going this direction. So the cumulus stage is the first stage, and it is normally associated with continuous updrafts, okay? That is the cumulus stage. As this gets bigger and bigger and bigger, then it reaches what we refer to as the mature stage. The mature stage, this is where you not only have the updrafts that we had talked about here before, but now you also have downdrafts that you have. You can also have a gust front that can precede this if the movement is west to east, which is the way most of these go. So what happens is you have this air that gets sucked up higher and higher and higher, and you can see right here they're showing 40,000 feet. I'm telling you that these things can get bigger than that, a lot bigger. So you can see that this air gets cooled and it gets sucked up here. As it does, the warm, moist air, it can freeze. When it freezes, it begins to hail. Well, I'm sorry, it doesn't begin to hail. The hail can form. So you can have hail that begins to form here. And here's what happens. This hail can then get over here and get on this downdraft, and then it can get moved around into the updraft. And every time that it creates this little loop like this, that hail gets bigger. So these great big mature stage thunderstorms can produce a tremendous amount of large damaging hail. And it can throw this hail also right out this anvil-sized point that can also form over these thunderstorms. So remember me telling you that you want to avoid the footprints of these thunderstorms. And when I say that, I'm not talking about just the footprint here. I'm talking about the footprint all the way over here. So this is a much larger area than you might imagine, because as I said before, what's happened to some pilots is that they thought, well, I'm going to cut the corner and I'm going to come right underneath the shelf of that to get around because I don't want to waste the gas to get around it. And they get showered with hail, and it can be the beginning of a very bad day. So don't do it. So, mature stage, lots of vertical development. Cloud tops can be in excess of 40,000 feet. These are big storms. Then in the third stage, which is what we refer to as the dissipating stage, this is a stage that is normally associated with downdrafts. This is when the energy is starting to leave this system, and it is associated with these downdrafts. As that happens, you can have rain, you can have hail, you can have big gusts on the ground here as well. So even though it's in this final stage of the thunderstorm, don't think that the excitement is over, because that can also be another big damaging area. But by far, the one that we want to pay the most attention to is when this becomes this. And that mature stage, because that's normally where the chaos really happens, again with the gust front out here as well. So you're going to need to know the 3 stages of thunderstorms, why they form, and to know what is primarily associated with each stage of those thunderstorms. And you can read more here in the chapter, more so than what I just explained to you. Squall line. This is a thing like that happens, and at some point I'm going to try to find that picture that I have of a squall line, and it was in 2007, I think it was, in 2007, and I have a picture of it somewhere. I wonder, and guys, I'm going to just take a quick peek here and just see if maybe I have that picture. Stand by. Do I have that? I'm gonna look. I don't know if I do or not. And I apologize about this. I'm just looking here. And I just wanted to see if maybe I had it on this iPad. It doesn't look like I do. I've got it somewhere else, and I'll have to find that. But I've got a picture, and what happens on the picture is that it shows a cross section of the United States. And what happened is that there was a squall line that began down here near Brownsville, Texas, down at the very southern end of Texas. And that squall line extended all the way here through Dallas, east of Oklahoma City, through Missouri, and all the way up here near Chicago. It cut the country in half. And some of those cloud tops were in the 50 and 60,000 foot range as it bisected the country. That night, it eliminated any east-west traffic. There was no getting around it. And so traffic was just parked because nobody wants to tangle with those things. You can't outclimb it. You can't try to find a sucker hole to get between it. You just call it good. You park the airplane, you go inside, you have a cup of coffee, you have dinner, get up the next morning and knock it out then. Because these things are just things you do not want to mess with. Squall lines here, again, that's what we're talking about here with the squall lines. Ever heard of a tornado? Yeah, well, that's thunderstorms can create these tornadoes as well. And those can also be the beginning of a very bad day. You can see here that in this mature stage of a thunderstorm, this is that part that I was telling you, where that anvil can extend out far in advance of the actual storm. This is that gust front that can develop out in front of it. On the lee side of mountains, or in not the windward side where the wind hits it, but on the back side of mountains, you can see this roll cloud that can develop. And a roll cloud can develop this way here with the speed of a tornado. And so it's like a sideways tornado that can form out there as this storm starts to roll through. So can you kind of feel me here a little bit, why I'm making such a big deal about thunderstorms here and not taking a chance on trying to flog an airplane through one of these storms? Yeah. Turbulence, you think? Aircraft icing. That icing can occur where you can develop icing on your airframe, which affects the weight of the aircraft. It affects the camber of the wings. It affects your ability to lift. It affects the ability to control your control surfaces. Bad news. Hail, yeah, we talked about it. Visibility is going to be a problem. Engine water getting into your induction system there, yes, that can also be a thing with this heavy rain that is associated with these storms, because your engine doesn't work real well trying to suck in water. So that's kind of a big thing here. So you just want to make sure that you try to avoid these areas. There are going to be times in your careers that yes, you're going to fly through rain. Yeah, you're going to go through areas like that. Rain is one thing, and if you look at the rain that's associated with a warm front advancing over a cold front, that's where you kind of have the gentle showers, but you don't have the severe weather associated with that rain. Avoid the severe weather that's associated with rain, because that rain is produced in quantities that your engine cannot perform at all, or maybe even stay running in there with that kind of water being sucked into your engine. So just know that is kind of a big thing. Also know the lightning element of this. A lot of people think, well, you know, the lightning, my gosh, that's got to be a real huge issue. Well, it can be, but it normally isn't that big of a thing. We have static wicks that we have on the backs of the aircraft to kind of move the static electricity that performs as we fly, It forms as we fly around the airframe, and then it kind of dissipates that static electricity back behind the airplane as we go through. Lightning normally is not that big a deal, but it has happened and it has created issues. You could lose your instruments, and that's kind of a big thing. But remember, normally a lightning strike on an aircraft is not necessarily associated with, you know, this catastrophic failure of all of your systems. It may be the instruments, but know that your engine, once it gets started, is on a separate system. And so as long as that engine is running, you know, that you're not going through water, whatever that may be, then that engine should stay running even if you lose everything else. So just keep that in mind. Lightning can happen, but I'm not going to tell you it's a non-issue, but it's not as big of an issue as the turbulence associated with a thunderstorm. So as we look here, that's kind of the chapter summary with that. And then from there, we're going to be getting into some of the weather tools that we have. So here's your assignment. You're going to have a quiz on this here coming up here in your next class. So on that quiz, it is going to be over weather theory. What are you going to be required to know? You're going to be required to know, how does weather happen? How does weather occur? You're going to need to know the fronts. You're going to need to know clouds. You're going to need to know fog. You're going to need to know what the dew point is and how it works. You're going to need to know as I mentioned before, the types of fronts, how they work, to be able to identify the types of fronts that you see on a map. And then also thunderstorms, the 3 stages of a thunderstorms, what the 3 stages are, how they're formed, and the consequences of each. Is one associated with updrafts? Is one associated with downdrafts? Does one get both? You got to know, okay? And that's going to be pretty much what we do in the junior phase. Once you get into high school next year and you start taking the real FAA classes, we get into this a little deeper. So just keep that in mind, okay? So that's your assignment, is to get ready for this quiz. Following the quiz, we're going to get into chapter 13. So we just finished chapter 12, then we're going to get into chapter 13. So study for the quiz and start reading chapter 13. Okay? All right, guys, have an awesome, awesome day, and look forward to seeing you soon. You guys take care.